Hello everyone, let me introduce myself. I am Facundo Carballo and today I will explain you all about channels, since why we have to use channels and how to implement channels in our Golang programs. So before we start with the video, let me ask you that if you like this kind of videos, please hit the like button and subscribe to my channel, because that helps me a lot to grow up on YouTube. So with that said, I will let you with the video. Another synchronization mechanism are channels. Channels allows to coroutines to put some message on a channel, and another coroutine will be listen for that channel, and this another coroutine can get the message from the other coroutine. It's a way to communicate two coroutines. Okay, so here in this diagram we can see like this coroutine put a message on this channel of integers, because every channel have to have a type, a specific type. Can be an struct, but have to have a type. If there is a channel of integers, we cannot put here strings. And the same for structs. If we have a struct of name, I don't know, dog, we cannot put on the channel of dogs another type of structure like cats. So we have to respect the type of each channel. In this case, it's a channel of integers, so this coroutine will put here a number, an integer, like for example 5, and this other coroutine will be waiting for that message. So if this coroutine came first and, well, there is no messages here on the channel, this coroutine will wait until this other coroutine puts there the message. So this coroutine that is listened to this channel can be blocked by the channel itself, because if there is no message, this coroutine will be blocked and will not execute until get this message from the channel. But if this coroutine put the message first, well, this other coroutine will get the message immediately and will execute with the other things that this coroutine have to do. So we will see this on code. I remind you, like always, that you will have all the code that you will see on this video, on this GitHub repo, which the link will be on the description of the video. So I recommend you that you have it closer to you while you are seeing this video, because it will help you a lot, okay? So going to the code. Here we have 6 functions: a producer, a consumer, and a with channel function, and another function that emulates the producer and the consumer, but this function is without channels. So first, we will see the without channels function to understand how we will have to implement these methods if we are not using channels. So first, look this function. In this function, we are using wait groups. I tell you that we will use wait groups in every method that we implement with coroutines. When we apply concurrency, we will have to use wait groups. We have here a resource variable. Well, this resource variable, we will pass it to these producer and consumer functions. These functions will execute in the background using coroutines. So this without channel will execute 2 coroutines, one to produce numbers and the other to consume those numbers, like we are seeing this here, but without using channels. So how we will do that? Well, we will do that using this variable here. And well, the producer function, what it does is generates a random integers every 3 seconds. So this is a for loop that never ends, but every 3 seconds generates a random integers, because here we are waiting for 3 seconds. And the same here on the consumer function. We are reading the number of this resource variable that we pass here, the pointer of this resource variable, and then we are waiting 2 seconds instead of 3. And that's because I want to show you that this consumer can print the same message twice, because maybe the resources are not updated by the producer function. In this mechanism, without using channels, maybe this variable or this resource that we have to producer and consumer, well, maybe the consumer consumes twice the same data, and we don't want that. But that are the risks to not use channels in this situation. So I will execute this function without channels to see what happens. Here the consumer reads 0, then the consumer reads 22, the consumer reads 43, 99, 99 again. So here is the example that I mentioned before, where we're using this without channels, a consumer and producer functions using a variable is dangerous because the consumer can consume the resource, the same resource data twice. So we have to use channels here because it's more simple and more safe. So we will see now the difference between the without channels function and with this other function that is with channels. So here we can see what it does, this function. Well, first, always we will need a weight group like so, and then we create a channel of integers. To create a channel, we have to use this, and here we have to put the type of the channel. In this case, it's an integer, but can be a string, a float, or any type that you like. Here we are telling to the wait group that we will execute 2 coroutines, and we will have to wait for those coroutines. And well, here is the same of here. We create 2 coroutines to execute a producer and consumer function. But here, instead of writing on the pointer of this variable, here we are writing to a channel, like so. The producer creates a random integer between 0 and 100 and put on the channel, like so. To put things on channels, we have to use these sentences. It's weird, but with time, it becomes normal. And then, well, we just wait for 3 seconds like we do here also. And the consumer, well, the consumer will create a variable n with the value of the channel. So here we are waiting. This consumer function will be blocked if there is no content inside of the channel. Will be blocked until the channel have something. So when the channel have something, some integer, we'll create this new variable n with the value that gets from the channel. So for example, if the producer function produce a number 5 and put that number to this channel, well, this consumer will read that number 5 from the channel and put here on the variable n, and then will print this number. Look that our consumer doesn't have to use a time that sleep to wait for the other number that our producer will provide us. We just have to print, and then we just have to wait here on the channel without using any time sleep. And it's better because maybe we don't know how long it will take to produce a new number on the producer function. So here, well, we just have to print every time that we can get something from this channel where the producer will be putting here new numbers every 3 seconds. It's like you can see here. This is the coroutine producer that will put here numbers on the channel, and this is the coroutine consumer that will consume the numbers that this coroutine producer put here. So this coroutine will get the number and print it, get the number and print it. If there is no number, well, this coroutine will have to wait here to get a new number from this. But this can produce deadlock. That is another problem applying concurrency. But deadlocks and all the problems that generates concurrency and this synchronization mechanism, it's for the other section. So now I will execute this with channel function to see what happens. It's the same that we see before, but now the consumer will never consume a number twice. Well, can consume the same number twice, but that is fault of the producer function because the producer can produce the same number in a row. So that's all for this video. I hope that you could understand why we need to use channels in our Golang programs and how to implement those channels. And well, I will ask you again that if you like this kind of videos, please hit the like button and subscribe to my channel because that helps me, really helps me a lot to grow up on YouTube. So, well, if you have some questions about channels or whatever, let me know on the comments. I will respond you. So well, see you on the next video.